Again, welcome to Unit 3 lectures. This is again college algebra. And today our main topic will be rational exponents and also radicals. So this is a review of basic algebra again. Again, rational exponents and radicals. How to solve rational problems and also radical problems, especially rational exponents. A rational exponent can be square root, cube root. We know square root is 1/2. Cube root is 1/3, etc. So a rational is a fraction, or a rational exponent means the exponent is a fraction. So our main objective is to define rational exponents whose numerators are 1. So again, square root is 1/2, cube root 1/3, fifth 1/5, etc. Also define rational exponents whose numerators are not 1. Also define radical expressions and how to simplify and also combine radicals. We're also going to learn how to rationalize denominators and numerators. So our first objective is defining rational exponents whose numerators are 1. So we have an example here. Here we have b to the power n equal to 1. B to the power n equal to 1. So n is our, again, exponent. Now, since we know that b equal to 1, a to the power 1/n, we have b to the power n equal to a to the power 1/n to the power n, which will give us 1. Again, what this means is we can say that if I have, let's say, any base value, in this case we have a raised to the power 1/n, and it's multiplied by n, we can see that n will cancel n, because 1/n multiplied by n will be n/n, which will be 1. So that's why our answer is A. Okay, we're going to solve an example soon. But the definition said, or the rule said, that if A is greater than or equal to 0, so A can be any base value, and n is a natural number, which will be our exponent, then a to the power 1/n, which read as the nth root of a, is the non-negative real number b, such that b to the power n equal to a. Now, b to the power n equal to a is the same as writing that a to the power 1/n equal to b. And that's what we have here. So again, we're going to see one example now, a couple of examples here. So for example, if I have 16 raised to the power 1/2, this is again rational exponent 1/2. It's a fraction. Since I know that 16 square, 4 square is 16. We have 16 here. So we know 4 square is 16. So it's the same as writing 4 square times 1/2. So 2 times 1/2 will be 1, or they will cancel. So because we know 4 square equal to 16, the answer will be 4. Because we're going to get 4 square times half, which is the rule that we have here. If we have a to the power 1/n times n, the answer will be a. So here, if we have 16 is the same as 4 to the power 2, and times half, 2 times half will give me 1. So the answer will be 4 to the power 1, which is 4. Another example here, we have 27 to the power 1/3. The answer is 3. Why? Because 3 to the power 3 is the same as 27. So 3 to the power 3 is the same as 27. So we can write 3 to the power 3 times 1/3. So again, the exponent 3 times 1/3 will give me 1. So it will be 3 to the power 1, which is the same as 3. Another example, we have 1/81 to the power 1/4. So I'm going to look for 4 to cancel 1/4. And I know that 3 to the power 4 is 81. So 1 over 3 to the power 4 times 1/4. So the answer will be 1/3. Because again, 4 times the exponent 4 times the exponent 1 over 4 is 1. So it will be 1 over 3 to the power 1, which will give us 1 over 3. And the last example, we have negative 32 to the power 1/5. Okay, I'm going to look for, if possible, I can look for 5 so that I know the exponent 5 times the exponent 1 over 5 will give me 1. And luckily, we know 2 to the power 5 is 32. So I'm going to write 2 to the power 5 times 1/5. And that will cancel. 5 times 1/5 will give me 1. And of course, there's negative, so the answer will be -2. So this is again simplified expression with rational exponents where the numerator is 1. And also we can summary of definition of a to the power 1 over n. Here we said that if n is a natural number and a is also a real number in the expression a to the power 1 over n, then if a greater than or equal to 0, then a to the power 1 over n is a non-negative real number b, such that b to the power n equal to a. All we are trying to say here is that if an exponent n cross the equal sign, it becomes 1 over n. That's the only simple rule we should know. So here I can say, okay, b equal to a to the power 1 over n. When a square crosses equal sign, it becomes square root. When a square root crosses equal sign, it becomes square. Now, we know in basic arithmetic that when we have a negative value of a root, example, square root, we cannot find the answer. But if the root is odd number, let's say a cube root of -8, the answer will give me -2. But a square root of -4, the answer will not give me -2. And there's no a real number. It's not a real number. So that's the rule here. We say that if the n, which is the root, it can be 2, 3, 1, 2, etc. If it's odd, then we have a real number. But if it's even, like 2, 4, 6, 8, then it's not a real number. That's when a is less than 0. So square root of any negative value, there's no answer. I say square because 2 is an even number. Cube root is an odd number. So cube root of any negative value, we are going to get the answer. Let's say fourth root, we are not because it's even number. Fifth root, we will get an answer because it's an odd number. So that's the rule here. So what's the strategy for simplified expressions of the form a raised to the power 1 over n? Again, n can be any value. Now the strategy is given here, and basically it follows the rule that we just went through. If a equal to 0, that's if the base is 0, we don't need to worry because we know 0 raised to any power, the answer is always 0. Now, if the a is a positive value, which is greater than 0, that's good. So here we can say that a to the power 1 over n, again, n can be any value, it can be even or odd value, that's fine. We will get an answer. And here means if we can simplify it and we get a to the power 1 over n times n, the answer will be a. So example given to you is 16 to the power half will be 4. Why? Because 16 is 4 square. So we get 4 square times half, which will cancel. 27 1/3 will give us 3. Why? Because 3 to the power 3 is 27. And since we have a power 3 times another power 1/3, the answer will be 1. So it's 3. Now here we have to be careful. We saw the rule. If a is less than 0, which means it's a negative value, if the n is an odd value, then we get a solution. If it's an even value, then we don't get no solution. So you can see here, our n is 5, our n is 3. So we can get a solution. we use the same step to solve it. But if our n is even number, there's no solution. So negative n half or negative 81 to the power 1/4 is not a real number. So let's move to the second objective. Here we should define a rational exponent whose numerators are not 1. Now, if the numerator is not equal to 1, it's very simple. We just keep cancel. We cancel the value. So here we can see a to the power m by n is the same as writing a 1 over n, then m will come out. Or we can put m down, then 1 over n. It depends. We know m over n is the same as m times 1 over n. Or we can say is 1 over n times m is the same. Now, when we have a negative rational exponent, we always change the expression by finding the reciprocal of the expression, or 1 over the expression. A reciprocal of a value means 1 over the value. So what is a reciprocal of 2? A reciprocal of 2 will be half, 1 over 2. So here, if I have a to the power negative mn, if I want to change the negative sign to positive, then it will be 1 over a to the power mn. Or if I have 1 over negative a to the negative mn, it will be 1 over a to the power mn. And that will give me a to the power mn. Again, the reciprocal. So this is a few examples here. Here they say we will apply the rules for the rational exponents. Here I have 25 to the power 3 and 3 by 2. What I will do is that I will take the 3 out first. So I'll get 25 half times 3. And I'll see if I can be able to solve this 25 by half as we did previously. Yeah, 5 square is 25. So I'm going to get 5 square times half. The exponent 2 times half will give me 1. So the answer will be 5 to the power 3, which is 125. Let's try the B. Negative x to the power 6 over 1,000 2/3. Okay, what I will do is that I will take 2 out first, then I'll use the 1/3. So you can see we have 1/3 and the 2 is out. Okay, so 6 times 1/3, it will give me 2. So I have x squared. 10 to the power 3 is 1,000. So I'll get 10 to the power 3 times 1/3. So that will give me 10. Then remember we have the 2 here, so that is the 2. So finally our answer will be s to the power 4. 10 squared will give me 100. Again here we have 1,000. So 10 to the power 3 is 1,000. So we are going to get 10 to the power 3 times 1/3. And 3 times 1/3 will give me again 1. So that's why we get 10. Let's try the next example, 32, negative 2/5. The first thing I'll do is to change the exponent to a positive value. So I'm going to take the reciprocal of it. So I'll get 1 over 32 2/5. Okay, I'll take the 2 out and use 1/5. So I'll get 32 1/5 to the power 2. Is there any value that can give me exponent of 5? Yes, 2 to the power 5 is 32. So I'll get 2 to the power 5 times 1/5. 5 and 1/5 will cancel again. We still have 2, so we got 2 to the power 2, which will give me 1/4. The next example, we still have a negative exponent again, rational exponent. So we find the reciprocal of 1 over 81 to the power negative 3/4 will give me 81 3/4. I'll take the 3 out and keep 1/4. Do we have any value that can raise to the power 4 and we get 81? And that is 3. 3 to the power 4 is 81. So I'll get 3 to the power 4 times 1/4. 4 times 1/4 will give me 1, so they will cancel, and I still have my 3. So it will be 3 to the power 3, which will give me 27. So next we're going to discuss about defining the radical expressions. So a radical expressions, again, is a root sign. So we say the radical signs can also be used to express root of a numbers. So the definition of here we have root n a, or if n is a natural number and is greater than 1, and if a to the power 1n is a real number, then root n a is the same as a to the power 1n. And we know this. A radical sign, again, means a root. So a to the power 1 over n is same as root na. So this is an example here. Normally, when we start with the 2, we don't write the 2. So if I write a radical sign with a, this means square root of a, which is 2. But we normally don't write the 2. From 3 going cube root, etc., we write it. Now, if I have a, this is the same as the previous rule we saw. If I have a to the power 1 over n times n, the answer will be a. Now we are using the radical sign now. So the root of n, a to the power n will cancel the n. The root, because root n is the same as exponent of 1 over n. So we get n times 1 over n. So it will cancel it. So that's the summary of what we just went. Almost this rule is the same as the rational expression rule. Radicals are also rational exponents. If I have a root n, a is the same as writing a to the power a rational exponent of what? 1 over n. So the same rule applies. If the n is a odd number, we get an answer. It's a real number, whether it's negative or not. We said if a is less than 0, which means if a is negative value, if the root is n is a odd number, it's good. If it's even number, then it's not a real number. So that was the same example we did for the rational exponent. 1/3 exponent is a rational exponent. Since 3 is a odd number, even if the value we are looking for is a negative, we still get answer. If it's even number, we don't get answer. And that's the rules here. But again, the rules are the same as rational exponents. So let's see one example here. Here we'll have a root 64x to the power 6. Same process we solve the rational exponent. Root 6 is 1 over 6 exponent. So I know 2 to the power 6 is 64. So I'll get 2 to the power 6 times 1/6. I'm using the root. So the answer will be 2. Yes, to the power 6. Again, root 6 is 1/6. So 6 times 1/6 is x. So our answer will be 2x. And it will be a positive value because the odd and even are not the same. If we have a odd root, our answer can be positive or negative. But if we have even root, it have to be positive. Negative, there is not a real number. So here to the same thing, we have a cube root of s cubed. I can write this as s cubed times 1/3. Cube root is a exponent, it's a rational exponent, 1/3. So that will give me x. Same thing applies here, square root. Everything is positive, so we are good. 3 square times half will give me 3. 8 exponent, but times half. So 8 times half will give me 4. So that's why s to the power 4. So now we're going to do the last section, which is simplify combining radicals. So the rule said that if I have here we have a n root a times n root b. If the root are the same value, we can multiply the two, so it will be ab root of n. The same thing with division. If the root are the same, we can divide the values and keep the root. So root NA divided by root NB is the same as A divided by B root N. So there are some numbers that are squares of positive integer. For example, we know 2 squared is 4, 3 squared 9, 5 squared 25, 6 squared, and we keep going, 7 squared 49, etc. These are called perfect squares. So for example, 4x squared, I know it's 2 squared, s squared, 1n is 1/3, etc. These are all perfect square examples. And also we have the cubes. We know this. 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed 125, 6 cubed 260. So these are called the perfect cubes. Now if I have 64s cubed, this is a perfect cube. Why? Because I know 4 cubed is 64. The same thing, 27 is 3 cubed, so 1/3 cube. Now let's solve some problem here, a very basic one. If I have 3 root 2 plus 2 root 2, I use the term root 2, but it's the same as a square root of 2. So I can say 3 square root of 2 plus 2 square root of 2. Now, since both is square root of 2, we are assuming the square root of 2 is the unit. So we are going to add 3 plus 2. It's the same as using the concept of like terms. So yeah, I'll get 3 plus 2, which is 5, and we keep the root 2. Next time we have 50 plus 200. They are all the same root. But there's a trick here. Previous answer was very simple because they gave us the unit root 2. 3 root 2 plus 2 root 2. So it's the same unit. We had 3 plus 2, then we get 5 root 2. Here we cannot add 50 plus 200. They are different. So what we can come up with, we will break the 250 down to see if we can get a common unit. And I can see that the 2 is a common unit because 2 times 25 is 50. 2 times 100 is 200. And I know 25, the root of 25 will give me 5. The root of 100 will give me 10. So that's how we solve it here. 50 will give me 25 times 2. 200 will give me 100 times 2. The goal is that I want to get a basic common unit among these two terms. And I know here I will get square root of 25 times 2, root 2 plus 100, root 2. We use the rule, we break it into 2. But I know that square root of 25 is 5, so I get 5 root 2. And square root of 100 is 10, so I'll get 10 root 2. So now we have this common unit now. In the previous example, this is how they give us the question. But sometimes we may have a question that we have to break it down ourselves. So the answer here will be 15 root 2 because 5 plus 10 and root 2. This is another example here. We have 3z. We have the fifth root now, 64z minus 2. The same fifth root 2z. But again, we can see that the 2 are not the same unit. So what we can do again, we can break it down here. Here is okay. The 2 is here, so we need 2 here also. We have z here, we have z6, but we need z here also. So what we did is that we break the 64 to 32 times 2z. To here, we don't even want to touch the 2 is already good. But the z6, we're going to break it into 2. We get z and z5. So you can see the goal is that I have only z here. So I need a unit of 2z, which I have now. So now I'll find the fifth root of 32. Then also I'll find the fifth root of z5. So you can see our red test, we break that one down. So we know the fifth root of 32 will give me 2. The fifth root of z5, of course, 5 times 1/5. the exponent will give me 1. So we get z. Then from here, we can say that we can get 2 times 3 is 6z. 2z, the units are the same now. Fifth 2z, fifth root 2z. So 6z minus 2z so here we can say that 64 minus 2z will give me 4z. And as we said, the units are the same, so we keep the unit. So we can see how interesting this question is. We look from the beginning of the question here. Let's look for the lower value. Oh, it's 2. Can I get 2 from here? Yes, 2 times 32. The lowest unit for this is z. Z6. Oh, I can make it z times z to the power 5th. And that's what we did here. And we tried to find the 5th root of z5, find the 5th root of 32, so that we have only 2z 5th roots. Now, since the units are the same, we can combine the two terms. So we get 6z minus 2z. And next is the rationalizing denominators and numerators. Rationalize, again, what it means is that we have to remove the radical sign. So if a question says we should rationalize the denominator, it means we have to find a way to take the root of 3. Take the root out. So the answer should be only 3. So that's the example they gave us here. Rationalize the denominator, root 5 divided by root 3. Okay, how can I remove the root 3 here? I'll just multiply by another root 3 because root 3 times root 3 will give me 3. Because it's square. Square root. Or we can break it down. We had a square root. Anything you do to the denominator, we have to do the same thing to the numerator. So when I multiply it down by square root of 3, I multiply the numerator also by square root of 3. Now, 3 times 3 is 9. Square root of 9 is 3. And 3 times 5 is 15. So the answer will give me square root of 15 over 3. Rationalizing the denominator, the goal is to remove the radical sign of the denominator values. Rationalizing the numerator means the goal is to remove the numerator radical signs. So here they say we should rationalize the numerator. So now, numerator is 5, square root of 5. So I'll multiply by square root of 5. And I'll do the same thing to the denominator, square root of 5, square root of 5. So that will give me 5 times 5 is 25. Square root of 25 will give me 5. 5 times 3 is 15. So the final answer will be 5 over square root of 15. We have a couple of examples here. So let's go through each one. Rationalize each denominator and simplify it. So 1 over square root of 7. Here, the square root 7. We have to take the square root out. So I'm going to multiply both the numerator and denominator by square root of 7. So this is what we get, square root of 7 by square root of 7. I'll get square root of 49. Square root of 49 is 7. 1 times square root of 7 will give me 7. So the answer will be square root of 7 by 7. Here also, first thing I will do is separate the two because we want to remove only the radical sign of the denominator. We don't want to touch the radical sign of the numerator. So we separate it. Now we have the cube root of 3 divided by cube root of 4. Since I'm trying to remove the radical sign for the denominator, and now I have a cube. So the best way to solve this problem, when it's square, you multiply the same value by itself and you cancel. But when it's cube, we have to be careful. You see, we are not using the cube root of 3 no more, 4. Because 7, square root of 7, we use square root of 7, we take it. But cube root, we want to find a value here that if we find a cube of it, or we can find the cube of it, we get 3. Since we know the cube root is 1/3, we also want 3 times 1/3 to make it 1. So the best way is using square root, cube root of 2. So we can see that cube root of 2 and cube root of 4 will give me cube root of 8. 2 to the power 3 is 8. So this means cube root of 8 is 2. So that's what we get here. Cube root of 8, then cube root of 8 is 2. And we know cube root, so 3 times 2 is 6, and it will give me cube root of 6. So we have to be careful. If it's cube root, you want to multiply a value with the value that we have so that you can find the cube of it. If I can find the cube of something, the cube and the cube root will cancel each other, and that will take the radical sign away. The same example here. So here, 3, again, we separate the radical sign, cube root, square root, over another square root. So square root of 3 over square root of x. We are removing the radical sign. So we can see here again, we take the radical sign. So we use, it's a square root. So when it's square root, multiply by itself, that's it. So square root of x times square root of x will give me square root of x squared. 2 times half will cancel. So we get x. So it will be square root of 3x over x. Here also the same thing we are going to do. Separate the numerator from the denominator. So we get square root of 3a cubed over square root of 5x to the power 5. And again, this is square root. So multiply by itself, square root of 5x to the power 5. So we multiply 5x, and that will give me 25x to the power 6. 5 squared is 25, so we take the radical sign away. 6, we get half times 6, to left with 3. And the top, we just multiply everything. So rationalize denominators and numerators. And the theory is that if it's denominator, remove the radical sign, numerator, remove the radical sign. Now, when we have a question whereby we have a root inside another root, all we need to do is to multiply the roots. So if I have a n root x, or n and m root x is the same as m times n root. So again, this will be the conclusion of our lectures, which cover again rational exponents and radicals. As we said again, rational exponent is the same as radicals. But radicals, always the numerator is 1. So half, square root, 1/3, cube root, etc.